All right, let's take a look at this system. Now, in the previous one, we saw that the z's could very easily go away, and we didn't have to worry about multiplying an equation times anything. If you look here, you might see something very similar. See, what I'm seeing is I've got a negative x, but then these guys here are both positive x. So, if I were to combine equation 1 with equation 2, the x's would go away, and if I were to combine equation 1 with equation 3, the x's would go away as well. So it'll create a system of equations with just y and z, but that's fine, because if you have two equations, two unknowns, it should be fairly simple to finish after that. All right, so let's do this. If I do equation 1 plus equation 2, so the x's go away, I would have negative 2y, 3z and 2z is 5z, 18 minus 17 is 1. And then if we combine equation 1 with equation 3, negative x plus x is 0, 2y minus y is just y, cool. 3z minus 5z is negative 2z, 18 minus 13 is 5. All right, seems simple enough. Now, if I needed to cancel one of these variables, my eyes are going to the y. Smaller number, I see I just need to multiply the second equation times 2, and I'd be right there. All right, so that means that we would have still negative 2y plus 5z equals 1. Distribute here, so it's not negative. What am I doing? Positive 2y minus 4z equals 10. So when I combine these equations, the y's go away. I have just plain positive z equals 11. All right, I've got one of these coordinates down. Now we got to go backwards and find the others. So I would recommend that you take the easier of these two equations, which to me looks like it's y minus 2z equals 5. So y minus z is 11, so that's going to be 22. And that means that y is equal to 27. All right, we're almost done. Now we got to go back to one of the original equations and find something that looks nice for us. So we're trying to solve for x. I think either the second or the third equation would be your best bet because it's just x. I think I'll go for the bottom one. I'd rather deal with the 5 than the 4 and the 2. All right, so let's see what we have here. So x minus y minus 5z equals negative 13. So x minus 27 minus 5 times z, which is 11. All right, so let's see. X minus 27 minus 55 equals negative 13. So let's see, 27 and 55 is 82. So minus 82 equals negative 13. Add 82 to both sides, and you get that x equals 69. All right, so putting all this together, that means that our ordered triplet XYZ is going to be 69 for X, 27 for Y, and 11 for Z. And again, we should be able to easily check this in the just by plugging things back in. Now, I'm going to use the graphing calculator to check. So let's see what that looks like. Now, the best way to do this is to use the store feature right here in your calculator. So I'm going to take, what is x? We said x is 69, so take 69, store that into x. Then we want to take 27 and store that into y, so we need to press alpha 1 to get to the y. And then we want to store 11, store into z, so that's alpha 2. So now, these values are stored into my calculator for x, y, and z. So let's type in these equations and see if it works out. So if I do negative x plus 2y plus 3z, according to the equation that I have in my notes, that should equal 18. Let's see. Awesome. But, you know, sometimes we get lucky. Let's try all of these. So x minus 4 alpha 1 for y plus 2 alpha 2 for z. Does this equal negative 17? Huzzah. Last one. X minus y minus 5z. Does this equal negative 13? And it does. Our solution is correct. I feel good. And hopefully you guys do too.